All right, we're looking at problem 8.15. It's got a squid and an octopus, and it's moving, or a squid, it's moving itself forward by propelling water. So it starts out, it's going to say my terrible drawing of a squid. We'll put it up here. Now, let's see how that works. Okay, now they got the very good squid, but in any case, it's got a bunch of water inside of it. We'll color that blue. Okay, 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 and it's still. And then it's going to take the same amount of water and it's going to expel that water. So we're going to have the squid like that. Again, I had a terrible squid, but we're going to take all this water and we're going to expel it out this way. Okay, we want to move it out that way. We also then want the squid to go out this way at 2.5 meters per second. We want to know how fast does this thing have to go in order to get that to happen. Okay, so that's what we're going for to start with. Okay, so we'll start with the momentum at the start. Oh, I guess. So that's the momentum at the beginning. I'm going to call each piece a separate thing. Okay, so there's our little equation. Okay, these aren't moving at first, so this is just going to be 0, this whole thing. Okay, and we're going to call M1 the squid itself, which is going to be 6.5 minus 1.75. They give us the squid and the water. Okay, okay, okay. And then so we're going to subtract that off because that's going to be the part that's left. We don't know the speed of that. Okay, but we do know for 1 point. Actually, no, we know what this needs to be. We know this needs to be 2.5 meters per second. Okay, and we know that we don't know how fast the water needs to go though. That's 1.75 kilograms, and we know that this is the speed that that has to go. So we multiply all that together, this stuff here. So we have 0 equals 11.875 kilogram meters per second. Okay, plus 1.75 kilograms times V. So we take 11.875, we divide it by negative 1.75, because we bring it to the other side. We get that V is equal to negative 6.79 meters per second. The negative is just telling us that our sign has to be the opposite of whatever direction the squid is moving. Part B of the problem asks us how much kinetic energy did the squid create by this maneuver? Well, we know that really transferred. I'm not excited about this word create here, but I mean, it is what it is. So, I mean, it transfers it. So, because at the start it has no kinetic energy. It's going to gain some kinetic energy. I'm guessing from the work that it does by its muscles to squirt out all that liquid. So, but all we have to do is find the kinetic energy of each part. So it's going to be 1/2 times 4.75 kilograms. Remember, that's the actual mass of the squid itself. It's the 6.5 minus the 1.75. Then we take the speed from the first part, which is going to be 2.5 squared plus 1/2 times the 1.75 kilograms. This is meters per second, by the way. Okay. And that's going to be times the 6.79 meters per second that we calculated in the first part. Okay. When we calculate the first, we get 14.84 kilogram meters squared over second squared, which conveniently works out to joules, plus the other part here, which we get 40.34 joules also. We combine those together, it's like 55 point. Oh, that looks terrible. So let's erase that a little. 8.18 joules. Okay, and that's the amount of energy that we created or transferred from the squid's body to the water and to the squid's body itself, the actual motion of the squid in kinetic energy.